So one of the hardest parts of the learning process is when we reflect back on situations that didn't go as well as we hoped. So Caleb Hattingh has generously volunteered to share some of the challenges he faced in introducing Python to students at CoderDojo and the lessons he learned in the process.
Okay. Yep, that's on. That's good. It's working. Okay, so teaching Python CoderDojo. I'm an imposter. I'm an imposter here in two ways. The first way is I'm not a teacher, unlike most of you. No training in education whatsoever. The second way is I'm also not qualified as a software engineer. I'm actually qualified as a chemical engineer. It just so happens that I've been using Python in the course of my work for quite a while, doing engineering calculations, modeling, simulation, reactor design, and that kind of thing. I really enjoy programming in Python, and in hindsight, I probably should have studied a different thing than what I did do. But I've switched now, and I've started a startup for teaching coding online. So if you're interested about that, ask me. But we're here to talk about the attempt to try to teach Python at CoderDojo. So my goals in the talk are pretty much just to give you a bird's eye view into what one of my classes is like, one of our classes, and go through some mistakes that a non-educator is likely to make, like me. They are many and various. And these are my observations only. They won't apply to any other mentors at CoderDojo, and they probably won't apply to any other CoderDojos. But it may be of some use to you if you get non-educators to do teaching for you in some capacity. So quickly about CoderDojo, you probably have all heard about it. It's a global movement. It's volunteer-driven. For us, it happens on Saturdays in the midday. The kids are a very wide range, so 7 to 17. That's pretty much like year 4, year 5, through to year 12. And I started in January, and I've been going every Saturday since then. I'm going too fast, so I'll slow down. But to give you a picture into what our class looks like, this is at the Chermside Library. Kids come in, they stream through the doors, we take down the registration details, and they set up, plug in. We try to get everyone set up on the Wi-Fi. The Wi-Fi doesn't seem to allow too many connections at the same time, so we have to stagger that over a couple of minutes. And that's pretty much it. The kids run on tasks, which I'll get to in a second. And at the end of the class, kids who are proud of what they've built and they want to present it to the rest of the class, they go up to a podium and they present their work and they talk through their designs. And here is one of our kids showing a Scratch design that he did. Kids really love presenting their work and getting feedback. So to go back to what a class is like, we don't run a taught curriculum. Kids come in, and the way our dojo specifically works, which is not the same as all of them, mentors pitch different ideas about what they would offer to kids, and then the kids decide what they want to do. The younger kids tend to be drawn to Scratch. We have 1 or 2 kids who use a thing called Alice, which is very similar to Scratch, but it's in a 3D world. And we've started then this year trying to push HTML and CSS so that kids can get web pages up. And at the same time, iPads are going. They're playing games. One of the kids would be playing music from iTunes. People are moving in and out of the room for bathroom breaks. We break at lunchtime. The class is a 2-hour class in the middle of a Saturday. So it's pretty chaotic, and it's pretty vibrant, and there's a lot going on. And kids tend to ask mentors when they want help with whatever they're doing. And it could be any of these things, or even none of these things. One of the kids might try something completely different. And into this maelstrom, I thought I would try to teach some kids Python. So in term 1, we mainly did Scratch and the web. And in term 2, I thought I'll try and introduce some Python, some basic Python to the kids. Term 3 starts next week, and I'm going to be doing that as well. And some of the lessons that I've learned, I'll be incorporating into term 3 syllabus. My first big lesson is, in that environment where graphical tools rule and they make sounds easily and colors easily, it's really hard to sell Python. It's really hard, unless you have a Pygame aspect going on, or you're connecting to Minecraft, or you've got some kind of Flash going. It's really hard to sell the idea that you type characters into a terminal and more characters come out. So that's kind of the expression you get from a lot of the younger kids. Like, they look at you like, really? I'm not going to do that. No. Never mind that. But I got a few kids. So before we get into that, just to give you a quick idea about what Scratch is and how it works, I think hands went up earlier to say that most people had heard about Scratch. A lot of kids use Scratch, and a lot of younger kids use Scratch, and they get very, very good at Scratch, really, really proficient. they build incredibly complex programs by dragging and dropping these blocks that plug in together like jigsaw puzzles. You can't really make any kind of mistakes. There are no syntax errors that you can make. That is completely removed from you. All you have to focus on is the logic and figuring out how Scratch interprets your logic decisions. I'm not that optimistic about the use of Scratch in the classroom, and that's just my opinion. You shouldn't take that as gospel, but from what we've seen, from what I've seen is being unable to fix syntax errors is actually a problem. When we transition some kids who are really, really good at Scratch to an environment, even just HTML, where they have to type the code in, small problems with syntax errors and joining blocks up and completing tags become massive problems in trying to get the project done. It's a huge stumbling block to try and have to deal with syntax errors when the kids already have a vague idea about what they want to accomplish. So it's like one part of the skill set has advanced much further than the other part of the skill set, which is dealing with things like syntax errors. Where did I save that file in my system? I can't find the folder. Did you save the file? Oh, no, I just closed it. I said no to the dialog box. How software works is insulated from you in the Scratch environment, the basic building blocks of Windows and how software works. And we see that immediately when a kid who does very, very good work on Scratch transitions into an environment where they have to type code in. And the other thing is typing. Being able to find the special characters on the keyboard turns out to be another huge stumbling block that delays the process of learning a great deal. To find where the $ is, to find where the greater than sign is, and that kind of thing. So what is interesting is that the kids develop the skills in thinking logically in Scratch, but fall short when they have to try to enter those ideas in a new language. And then on top of those basic problems, you also have the problems of learning a language and the abstraction that Peter spoke about earlier. But that's just about Scratch. So what we're talking about here is kids who have already done Scratch in the past, become very good at it, now they've transitioned into a mindset of wanting to learn Python. So I got a couple involved, Corey, Henry, and Dan. They said they were going to do it and they were going to give it a try. So Corey wanted to do Code Academy. He had already started on some of the lessons, but he was struggling and he was hoping to get some help at CoderDojo. Henry and Dan and I got them set up with the PyCharm Educational Edition. The Education Edition comes with a Learning Python tutorial built in, and I thought that was great, and Code Academy's Learning Python course is great. It has many users. And the plan was that they were just going to do the exercises presented to them in these, and then myself and a couple of the other mentors that knew Python would pitch in to help with some of the questions as and when required. But basically, the lessons would run themselves, right? No, that doesn't work. That doesn't work. The problem is not with the tools. The problem is with my approach to teaching, which is terrible. It's a terrible way to do no lesson preparation and think that tools are going to solve your problems. The most important thing was, despite that these tools are good, they're pitched at a much higher level than what these kids are at in learning to code. I don't think that it's wrong to introduce Python at the age groups that they were in. We're pretty much looking, so Dan was about 11, and Corey and Henry were 12 to 13, that kind of age group, right? So year 6, year 7, year 8. These tools are great, and their content is great, but they're way, way too advanced. And this is what I discovered in the process of doing the teaching. So first we'll do Code Academy. I'm not criticizing Code Academy. It's a great tool, but what I want to point out is some of the problems I observed firsthand with kids that were too young trying to do these exercises, the things that jumped out at me. So this is the Code Academy screen. It runs in the browser. You get a question on the left, and you get your input area on the right. The example on the left gives you a string literal on which you call the function lower, and what it does is it produces a lowercase version of the thing. The task is to call lowercase on the variable name parrot, right? All of the kids who did this example tried to lowercase on Norwegian blue, which is also string literal. Every single one did it. They checked the example on the left, and they put lower on the right, and couldn't understand why it didn't work. They didn't read all the text, because there was an example, so they based what they did on the example. This is an example of something that happened over and over again with many questions. The example would be subtly different in a structural way to what the task was. And that was a huge problem because the examples were actually causing confusion rather than helping with the task. So I think if you're going to present examples to kids, especially younger kids, the example should be a pretty good match against what the task actually is. Instead of calling it on a string literal, rather call it on a variable name in the example so that when they do it in the code, it looks the same way. Here's another typical question. I think this comes up multiple times. So use of the word modulo. Modulo is a word that does not come up in normal speech. It's entirely used in programming languages. So when that word appears on the page, the kids think of nothing else but the strange new word that has appeared. Maybe we should call it remainder if we're teaching younger kids to code, because when they've started doing math in school, they already have dealt with remainders. You divide a number into another number and there's a little bit left. That's an obvious concept. Modulo is not an obvious concept. So even though what is happening is easy, the use of the wrong language makes it very difficult for younger kids to learn. And computer science is specifically bad with this. It's filled with jargon, just like chemical engineering and many other fields, where we use different words to mean things that have everyday meanings. One more. This was something that came up a lot as well, is that their instructions are given in various places in the page. So the kids didn't know should they follow what said there or what it should follow there. It's a very busy screen, and again, using different words to mean commonplace things. This description here on the top left says string. Now let's look at string. Less straightforward. String method turns non-strings into strings, for example. And then the example works with numbers. This is something that happened frequently. The example that would be given would be structurally different to what the task was. We should probably also call strings text if we're working with younger kids for programming, because the word string to be used to refer to text is not very common. It's common in programming. But as soon as you introduce a new word that has a different meaning from the commonplace term for the same thing, it introduces complexity, and managing complexity is off the charts difficult with stuff like this. We haven't even got into the logic of the code yet. This is just how the question is phrased. Okay, so PyCharm. I hit that too quickly. Yep, PyCharm Education Edition. It's a great tool. It's a fantastic tool. I should have done what Thea suggested, which is make my own exercises, but I didn't. I just used the built-in Learning Python tutorial, thinking that it had already been curated or tested in some capacity, and it would be suitable. It's suitable if you're old enough to understand and possibly have some exposure to programming before. If you're new to it and Python is your first language, to start with, there's a huge information overload. But in this particular question, I want to draw you to something that happened frequently in the PyCharm Education Edition in this set of learning exercises. The variable name is matching the contents of the variable. Hello equals hello. World equals world. This happens over and over and over and over, question after question. And the kids would call me over for every single question to ask, okay, so which one is the thing that I need to do? Right? Hello versus hello. A much more complicated question, greetings versus greetings. In this particular case, greeting gets defined twice, and the second one overwrites the former one. And the screen is really busy as well, right? There's stuff happening on the left. You don't know what's going on the bottom. The text of the task is quite long. Young kids do not read that much. I try to get my kids to read, but they don't like to read that much. Greeting versus greeting. Okay, and this was another thing that was symptomatic of the built-in exercises. Thea's exercises are much better. They're simpler. They're more to the point. This does not roll off the tongue. Boolean operators compare statements, return results, Boolean values. The Boolean operator and returns true in the expressions, blah, 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 blah. 10-year-olds do not read that. They don't understand the first word in the sentence, because Boolean is a word that does not get used in commonplace speech. It actually just means true or false, on and off. That's all it means, right? But when the word is introduced, young kids, they don't understand. And when you don't understand what the first part of the question is saying, you're pretty much guaranteed not to understand the last part of the question. It's kind of like that. That's how it reads to them. They don't know what it means or where it's going or what it's about, and they don't even do the question. Sleepy, very sleepy. That's incredibly dull. The one last bit that I wanted to mention that was surprisingly confusing to the kids, but maybe it shouldn't be, is the way the questions are structured in the default course for Educational Edition is that the instruction is written in the place where you're supposed to change the text and put the right stuff in. But the kids thought that was part of the program, and they couldn't understand whether they should delete that or add onto it or make a new line and enter the right answer. And of course, the fault is mine, right? Not the education edition. It was my fault. I didn't explain to them how that works before letting them do the exercises. So it became pretty clear the first day that we introduced these that they would call me over and they say, I don't understand, where do I begin? Okay, you do this, then you do that, then you do that. Great, they get the question right, they move on to the next question. The same questions come through again. Not the fault of the software, my fault. I did not think to explain any of those details that we just went through. And this is a problem where I would like to be spending my time explaining how to structure their thoughts in code. But I spend all my time explaining these other things, what words mean, and how to enter the instructions. So despite using very good tools that many, many people use to learn programming, it failed in our situation because the kids couldn't understand the questions. They couldn't understand what needed to be done. So it was really challenging. And I was struggling to think how I would go about this. What should I do? Should I look online? Should I try and find exercises that someone else has said it worked? Will it work in our situation? Did they do their exercises for older kids? I've got younger kids. They have particular needs that may not work for the other exercises. Need a plan quick. So what I decided to do, which is what I should have done in the first place, was make my own exercises. Granted, I probably would have made exercises that were too difficult and made some of the same mistakes without having had the experience of seeing what the problems were. So in hindsight, I think it was actually beneficial for me to have experienced those real problems. Not so much for my kids, because they were frustrated and ready to give up and just try and do something else. So my strategy was this: strip everything away. I installed a text editor for them, and I showed them where the command prompt lives on their computer, and we got Python going. And I showed them that if they put some Python code into the text editor and they save a file, and I show them in the file manager where the file is, then we make the command prompt change into that folder, and then they can type Python space file name, and then the code runs. That was my strategy. And then what code would we do? Based on my experience of using the previous tools that were exceedingly complex, I decided, well, if I'm going to make a mistake anyway, I'm rather going to make a mistake in the direction of having very, very short code. Do as little as possible, try to do something real world, and then the kids can edit it and make it change what it does. That was my strategy. And it turned out that that worked exceedingly well. For these kids at their ages and where they were at, this was incredibly successful. It turns out that starting with something that actually works is much better than starting with something that's broken and asking them to complete it. Because they make broken things along the way, starting from something that works. They can break it and see, okay, that change doesn't work, but I want it to do this. How do I do that? And then they can change, and then they can evolve while keeping the program working into something where it works differently. So I have a couple of examples of the exercises that I dreamed up, and I don't make the claim that they're the best examples. Probably we could come up with something better, but they are what I dreamed up, and I had a bunch of them, and I pitched them to the kids to whichever one that they wanted to get started with, whatever they were drawn to, and then they would open the code in the text editor, look at the code, not really understand what it said, but they could run it in the command prompt and they could see what it produced. And then they asked me questions about the code, said, okay, well, can I make it rather say this? I wanted to do that. How do I change that? How does this work? And then I could answer their questions. I could say, okay, well, if you want to do that, then you use a loop like this. And basically, this walks over this thing until that condition is true. And they could play with it, true and false, increase number, lower number. So this was our first program that I got them started in. The beauty of Python is that's a complete program. 4 lines, complete program. And it does something. What that program does is, if you run it on the command line, any text you type after the Python file name will be returned to you in uppercase. So it's really just it's a command prompt wrapper around the uppercase function in Python. So the kids got that into their text editor, and there was nothing else on the screen. That was all they could see. It was just those 4 lines. So even though there's some complexity there, there was no noise. So they could ask me, what does that thing do? Import sys. And I could say, oh, that loads a library for system functions. It can let you do stuff, like that argv there comes from sys. Oh, what does that do? Oh, argv, so the stuff you type after the Python file name, it gets in that thing, and then you can stick it into that text over there. Okay, that's interesting. What does join do? I said, oh, you don't need to worry about that. We'll get to that later. What does print do? Oh, that prints to your screen. Doesn't print to a printer. Okay, good. So they could run it, and then I would ask them, if you wanted to make a different program that produced all lowercase letters and not uppercase, where would you go? How would you begin? What would you try and approach? Corey thought about it for a minute, and then he said, maybe we should change the word upper to lower. Would that work? And I said, try it. Let's see. Let's give that a shot. Changed it to lower, and it works. And he now has made a new program from this program that does what he intended it to do. And then I could show the kids how to find where all those things appear online and go to the Python documents, and they can type it into Google, and they can find an example on Stack Overflow or something that can show you how it works. This was incredibly successful. This was the first time they actually did any code. And we did 3 days of Code Academy and PyCharm Education Edition. So 3 Saturdays we wasted on those exercises trying to fight through the difficult questions. And this was the first time with a small 4-line program that they actually felt that they were doing something. Complete program that they could run, produce output, and then start tinkering with. Guess a number. So here we have a while loop where we guess a random number, and we keep getting a message to the screen saying, guess my number, guess my number. So Henry said, well, it's really hard to guess a number. If we make that 100, it'll take forever. So then we said, well, what about if we give feedback on the number? If, maybe we can say you're too high or you're too low. What could we do there? So Henry said, okay, he'll try and make those changes. So we put if statements under there, and he played around with that for pretty much an hour and a half, trying to get the if statements working, and I would tell him how the conditions worked. He put his own messages in. He changed all that text to make it a bit more fun. And he started with a small program, and he made a better program based on one that was working. And every time along the way when he would make a change, he could see what the result of the change was, whether it worked or not, or whether the logic worked in the way that it was supposed to. Passphrases. This code here is a tiny version of the code I use to generate my passwords online. Slightly more complicated than the other ones, but what I found was you don't need to get hung up on the syntax. Kids can avoid things that they don't really understand. As long as it works, they can focus in on the bits that they're interested in changing. So that Google 10,000 English is a word list, big bunch of words, and for range in 4, it just draws 4 random words out and prints them to the screen. That's what it does. Picks 4 random words and prints them out to the screen. What if we do range 100? What if we range 1,000? Oh, well, that will work too, but it's a pretty big password. You can't remember that. You can't type it out. Then we start talking about, well, why 4? Why not 8? And then we go into a discussion about online security and why you should use a different password for every site. And with this particular question, some of the parents got involved at CoderDojo, and they started saying, well, I use the same password everywhere because I can't remember them. And I said, well, that's really bad because when one of your sites gets hacked, the hackers try that same password on all the other sites with your email combination, and then you get breached everywhere. And one of the kids, Dan, he had a Mac, and he knew the key combination to get the emoji window. He opened that text file up in the text editor, and he deleted all the words, and he put bunches of emojis in there. And then he modified the program so it would print out random strings of emojis, which I thought was kind of interesting. I wasn't expecting that to happen. He thought that was really cool, random emoji faces. Okay, and the last example was a fake virus scanner. It asks in the beginning, do you want to scan for viruses, yes or no? And if you say yes, it prints out dots randomly, and then at the end it says virus detected. And the kids had a lot of fun with this, and they wrote terrible things at the bottom about what was happening to your computer. Your hard drive is getting deleted. And we started talking about, well, how do actual virus scanners work? What do they look for? Do they look for files, special file names? And we started talking about how computers are, the structure of computers and how you have the disk and you have memory. And when you attach your computer to other systems, things can get copied over the network. So we start discussions on these simple programs into more complicated areas, and they start to think about what they want the programs to do rather than get hung up on the syntax. So the output of that looks like that. So it says, do you want to scan for viruses? If you say yes, then it prints dots randomly, and then it says virus detected. And the kids took that basic framework, and they built onto it, and they made it say other things, and so on. So by week 6 in term 2, so the last 3 sessions, we were working this way rather than we had in the beginning, and it was much, much more successful. The kids gave me great feedback. They said, at last, it finally feels like we're actually writing programs, and we know how to run them, and we can make our programs do things. Corey asked, well, my fake virus program, how do I get that on someone else's computer and make it run when they log in? You know, I think he said terrible things like your hard drive is being deleted, and we're tracking you, and things like that. And we could get into discussions about real-world issues, about security, and about where to keep your files on your computer. Well, what if you keep them in the wrong place? You can lose your files, and so on. How the computer actually works, right? And that's the picture, the graduation for our week 6 term 2 CoderDojo with all the kids holding up their certificates. That was really good. That was a lot of fun. I'm looking forward to term 3. And that's it. No questions, good.
Thank you very much. Sorry for the lack of a 5-minute warning. I was paying too much attention.
I had a timer.
My question would be, why do you think it's only children who need to have this sort of stuff when they're learning Python? Us adults wouldn't have minded having that too.
Yeah, so that's a great point. I don't think it actually is only children. I think once you know how to program, you're extremely biased in your approach to teaching it. I think it's a real problem. Teaching programming, I think, is quite different to teaching most other things. So until the kids are telling you they don't understand what's on the screens, you don't really understand what the problem is.
My question is, if you had your time again, would you make a PyCharm activity and build upon that? Because I guess my only issue is if I give a student a program like pick a random number, they can edit the little bits and pieces inside it, but they can't really build up from it. They've basically got a block, but they don't know what the block's made up of. So would you use PyCharm and give some comments here and there within the activity to describe what's going on? Or would you continue to use functions that already exist and let them play around with it?
At this age group, I would continue to doing what I'm doing now, simply because it's working so well. I think introducing the IDE later at some point probably has value, definitely real-world value. Many people use PyCharm to develop code. But I think working with the basic building blocks of files and the terminal and running your program on the command line, giving arguments to it, making it spit out other stuff that goes, I think that has real value because it does something real. And when the kids decide that they want to change a piece of code to do something else from what it's currently doing, I think they're learning. They're absolutely learning. And any bits of the language that they need to take on board in order to accomplish what they're doing is part of that process. I think the desire to get something to happen is stronger than their desire to learn bits of the language.
Do you think it's a good idea to add to your curriculum the concept of reusability? So maybe in the future, when they advance a bit more, you show them existing scripts and the beauty of actually using an existing script rather than, because this the teaching programming and learning it, the assumption would be I have to create everything whenever I need to do a task. But adding this concept of reusability at early stages, do you think could be useful as well for kids?
I could not say no to that. I think that's the only right answer is yes. What I've shown you is desperation, right? If I had more time, if I had training, probably I might have structured it differently. I think the other people who spoke today have much stronger framework for how to teach these things. I saw definitely an approach that does not work, and I did that, and that was my fault. But yes, absolutely. I think I looked for something that worked at all, right? And very short, complete programs seems to work. That seems to work and be really good. And I think we can grow from here as the kids decide what they want to do now with the code. Once they start getting an idea about what they can manipulate, I think those things will come in. If I see they're copying the same function over and over, I can tell, well, that looks similar. Maybe you should just make that one function. You can just change it on the argument. It looks like this. You call it. You give it some. I think that will develop naturally. At the moment, this is just the times of desperation to try and find a way to get them writing Python at all. At the back?
Was I the one at the back? So firstly, all of the things that you said about the notes in these teaching tools, how they use terminology too much instead of explaining things using simpler terms, how the examples are not, the variable names are very poorly chosen and stuff. I absolutely agree with all of that. I'm in the process of rewriting a chunk of the Grok notes, and I've been seeing cases of that and fixing them as I go, so I absolutely agree with you on that. My question is, as you're doing command line Python, how much time do you need to spend with the kids teaching them how to use a command line?
Oh,
They're
2
not
minutes.
used to running programs which take arguments on the command line. Is that something?
2 minutes.
They pick up that really easily?
Oh yeah, open it, type that. Which is surprising to me. I thought we would spend a longer time to do that.
Yeah.
I thought changing folders was going to be a really big deal.
Yeah, with CD. So what
Couple
kind of
of
command
minutes.
line? Is this a normal Linux command line? Like
Windows.
oh, the Windows command prompt.
Windows. We have maybe 2% max in our class. So
Yep.
to give you, I should have mentioned that. So in our dojo, we have about 30 kids, and I think that's more or less the same at the other dojos. The wait list is 50 to 60 kids, and there are 5 dojos in Brisbane. It's an enormous wait list to get into these classes.
What is your boy-girl ratio?
Very low. At my particular dojo, I think we have 2 or 3 girls, depending on the day, to 27, 28 boys.
Okay.
And none of the mentors are women either, which is quite bad. I would like to change that. I'm not sure how to do that. Perhaps if we had a better ratio in the mentors, that might work.
Hey, so I just wanted to speak to you. So last year, I did a 2-hour workshop at OzCon, the first Kids Day, and I was asked to teach command line Python. And now I teach programming to kids and have done for many years, and use a lot of, at that stage, I'd used a lot more multimedia tools to do it. So it was a really big thing for me, and they gave me this, the DevOps guys had already designed this thing, and then there was a random number generator, and there was a Fahrenheit to Celsius converter, and I just threw it out the window. I totally threw it out the window. I'm not going to take, I've got 6 to 18-year-old kids, and you want me to, who the hell cares about Celsius to Fahrenheit? I'm teaching American kids like they care, like any kid cares at that age. And also random number generator, great, but what is its real world application? So what I did was I kind of went, how did I learn to code? I learned to code by writing games on the command line. So what I did was take the way, they were teaching the basics, but I took it, and each of it, we kind of created a turn-based game. And this is all up on GitHub as well. We created a turn-based game, and then each kind of step we'd go through, we were learning a different set. So whether here we're learning strings, then we're learning to pull in integers, etc. And we get to the point where we actually pull in a random number generator when we want to add a dice. So we're not just saying 1, 2, 3, but we're actually rolling that dice. The response I got from the kids, this is in 2 hours. The response I got from the kids was amazing, because at the end of it, I've gone, now here's this, and it was a, Game of Thrones is pretty popular, so it was okay, this is a dragon slaying game. And then I went, now go off, and now that you've got this, I want you to hack this code and make it into your own stories. I had this, it was amazing. I had about 15 or so kids that were just like, come and see what I hacked, and it just kind of blew my mind away, because for me it was really, oh my God, how the hell am I going to teach kids command line in the year 2014? And they loved it. And we forget, because we forget that's how we learn. And we also forget that the power of actually seeing the computer talk to you as well, because that's what you're doing in a command line game. So I find doing the command line Python, I found taking that game approach a lot easier, because a lot of the structures out there just really use random things that just make nothing, and you really need to pull it into meaning for the kids to see that. And I've had a couple of them when I didn't do Kids Day this year, but when I was at OzCon, I actually had a couple of parents come up to me and go, oh, my child has kept on doing that work, and etc., which was quite nice to hear. have you thought of, taking that approach in regards to like pulling it into, I just find gaming, teaching kids anything in regards to games gets them interested.
I would be very interested in that GitHub account.
Cool.
All
Thank
good.
you, Caleb.